Okay, today we're going to be looking at Module 5. And Module 5 has two big things in it. We're going to talk about some different kinds of reactions, and then really the big thing that we get to in the second half of Module 5 is the mole concept. So we'll save that for a separate video, but we'll just deal with what is probably a far easier segment of it when we talk about three different kinds of reactions. So we're going to talk about decomposition reactions, formation reactions, and then combustion reactions. And the combustion reactions we're going to divide into two different categories. So the whole point of this is if I give you a compound, let's say that it's just represented by AX, and those are not really elements, those are just two symbols, that what I want you to do is to break that compound into its constituent elements. So on this side, I have an A and I have an X, and on this side, I need to have an A and I need to have an X as well. So let's have a look and see how that goes. First example is one that you're familiar with. It's the water molecule. So I'm going to give you the compound, H2O, and what I'm asking you to do is to write out this part of it here. The fact that if you decompose water, you're going to decompose it into hydrogen and oxygen. And you need to always remember that both hydrogen and oxygen are homonuclear diatomics, so they're always going to be H2 when they're in their gas phase. And if we write that out and then balance it, I know that it takes two liquid water molecules, that could be a gas actually, two water molecules that if I decompose it, I form two hydrogens and one oxygen molecule. That's what we mean by a decomposition reaction. So now let's walk through a specific example. Here I have calcium carbonate. If you look at this, keep in mind that the Ca, that's not going to be just carbon. That small lowercase a always is going to go with the capital. And so Ca is calcium, and then this is carbon, and that's oxygen. So go ahead and write out for me the constituent elements of this calcium carbonate. Put a C over here, or excuse me, a Ca over here, plus a C, plus an O2, and then we will balance that. And I'll pause I'll let you pause the video, and then I'll come back and write that out and balance it with you. So here we have our calcium carbonate. If I'm going to do a decomposition, I'm going to break it down into each of these constituent elements. So this is my reactant side. On my product side, I'm going to have calcium on this side. I'm going to have carbon on that side. I'm going to have oxygen. And I'm going to remember that oxygen is always a homonuclear diatomic. So whenever I finish, it's going to be O2. Now I have all of the constituent elements on the product side as we're on the reactant side, and now simply I'm going to balance it. And so I have one calcium over here, one calcium over there, we're balanced. I have one carbon over here, one carbon over there, we're balanced. Over here I have three oxygens and two over there, so I'm going to have to do a little bit of work to get my oxygens balanced. The easiest way to do that, as you're familiar with, I'm going to make this 6 oxygens over here. So I'm going to find some common factor between 3 and 2, and 6 is going to be it. So 2 times 3 will give me 6, and over here, 3 times 2 will give me 6. So I've got my oxygens balanced. Of course, now, after I've added that 2 in front of this molecule, I need to balance these as well. So I'm going to say that I have 2 calciums, and then I'm also going to need 2 carbons that are associated with that. So I have balanced my calcium carbonate. Okay, now I'm going to have you do this one. This one's potassium chlorate, KClO3. Go ahead and break it into its constituent elements and then balance it. And then I'll walk through that with you. Pause the video and then we'll go through it together. All right, so we start off with our potassium chlorate. And I should have mentioned this earlier, the S subscript, that just means it's a solid, so we're telling you what phase that molecule is in. So to make this into a decomposition reaction, I'm going to go to potassium on this side, chlorine on this side, and oxygen on that side. You need to know that just like oxygen is homonuclear diatomic, chlorine is. So that's something you just have to memorize one way or another. Okay, so now I have my oxygen over here, my chlorine over there, and my potassium over there. So if I look on this side, I have one potassium and I'm good there. I only have one chlorine on this side and I've got 2 on that side. So let's go ahead and just see if we can balance it this way. Let's make the chlorine right. And now I have 2 chlorines on this side and 2 on that side. What effect does that have on my oxygens? Well, I now have 6 oxygens on this side, but I only have 2 on this side. Well, I can remedy that pretty easy by making that balanced with 3 oxygens on that side. So I'm going to end up with 3 oxygens that are going to be a gas. I'll put a G there. My chlorine molecule, that's going to be a gas there. And, oh, I got to do there we go, 2 potassiums there, and that's going to be a solid, that metal. So that would be a decomposition reaction of potassium chlorate. And I know you can't see my 2 that I wrote in front of that K, but there's a 2 in front of that. All right, about 6 minutes in, and we've done 1/3 of our topics. So the next topic is going to be that of dealing with formation reactions. So we've done decomposition, now we're going to look at formation reactions. In a formation reaction, it's just the opposite of the decomposition. We're going to start with some individual elements, and we're going to combine them to make a compound. And so once again, our AX, A sub X's, those are not really elements. Those are just generic representatives of an element. So for every element on this side, it's going to have 1 in the compound on the other. So here I have just the opposite of what I started off with over there. I have the products rather than the reactants. So I want you to go ahead and write out the formation reaction for water. And of course, that's going to be just the opposite of what you did above. So you should be able to write out that equation. I'm going to give you a second to do just that. So here's our formation reaction. We're going to make water. Well, we know that if I start off with my constituent elements on this side, I have to have hydrogen over here, I have to have oxygen over there. Both of these are homonuclear diatomic, so I have to have 2 hydrogen and 2 oxygens, and now I simply want to balance it. So I might as well start with my oxygen in this case because I have 2 here and 1 there, so I'm going to have to make this a 2 so that I have 2 on both sides. And now, of course, I have 4 hydrogens over here, but only 2 there. So I make that a 2 there. And now I end up with my hydrogen. I'm going to say that's a gas, a G there, a G there. And here, this could be a liquid or a gas. I'm just going to leave it as a gas. There we go. And that is the formation reaction of water. And the next one, this is going to be pretty easy too. This is sodium oxide. All right, so go ahead and write out the constituent elements on this side and balance it, and then we'll walk through it together. All right, so here is our product for our formation reaction. I know that I'm going to want sodium on this side, that's Na. I want oxygen on that side, that's always going to be O2, and it's going to be a gas. So now I simply balance it. Well, my oxygens are already balanced. My sodium is not, but that's a pretty simple fix. I'm going to take sodium. And now we have our balanced sodium oxide. Not so bad, is it? So now we're going to do diphosphorus pentaoxide. This is going to be a covalent compound because neither of these are metals, and so we're going to have to name it a little differently. I'll just remind you from last module. And I give you a clue here to say that there are going to be 2 of these in the product. So go ahead and write it out in constituent elements and then balance it. All right, so I went ahead and pulled the 2 out because that was just a hint. So we're going to go ahead and walk through it. We know that we only have 2 constituent elements on this side, so I'm going to need phosphorus over here, and I'm going to need oxygen. Oxygen is always going to be homonuclear diatomic, so I'm going to make it an O2, and I'm going to leave it as a gas. And now I'm going to try to balance these 2. I have 5 oxygens on this side and 2 on that side. How in the world am I going to balance these? Well, one of the tricks we can use to balance them is I can kind of force this one to equal 5. Right now it equals 2 oxygens, and that equals 5, but I could force it to equal 5 just by saying that I have 5 halves of oxygens, all right? And because there's 2 of those, 2 O's for each one, that would be the same thing as making 2 times 5 halves, and if I say 2 times 5 halves, that will equal 5. All right, so now I've balanced my oxygens, and now I still got to balance my phosphorus. So I'm going to say I would need 2 of those. All right, so now technically this equation is balanced. However, it doesn't have a simple whole number ratio, so I got to get rid of that fraction. And I'm going to do that simply by multiplying it by 2. And when I multiply that by 2, I also have to multiply everything else by 2. So we're just going to rewrite this. If I have my oxygen, if I multiply 5 halves by 2, I'm going to end up with 5 of those guys. And if I multiply my 2 phosphorus by 2, I'm going to end up with 4 of those guys. And then on this side, I'm going to multiply all of this by 2. So it's 2 times P2O5, and that's going to be a solid again. And now I have my balanced equation. And what I've done is I've done a formation reaction of diphosphorus pentoxide. Okay, not so bad. Well, we've got 2/3 of the way. Now we're just going to finish up by talking about 2 different kinds of combustion reactions. One is complete and the other is incomplete. Let's have a look at that. Well, let's simplify or let's get rid of us stuff about formation reactions, and we're just going to focus now on complete combustion reaction. And for Wiley's book and for our class, we're going to limit combustion to being combustion of organic compounds. And by organic compounds, what we mean is they have to have carbon in them to be organic compounds. And so here I have a quick example. This is a methane molecule. And you don't have to know that methane is made up of 1 carbon and 4 hydrogens, but it is. You can see 3 of the hydrogens kind of on that methane molecule. There's another one on the backside that you can't see very well. But what you need to know is this, is that in any combustion reaction of organic compounds, oxygen is always going to be a reactant. So even though I don't tell you that oxygen is a reactant, if I tell you it's a combustion reaction, you need to always know that oxygen is a reactant, and oxygen is always O2. And here's another thing, is that the products of a complete combustion reaction are always going to be carbon dioxide and water. And so oxygen is always a reactant, and carbon dioxide and water vapor are always produced in the reaction. So when I give you an example here, like writing out the combustion reaction for ethane, I don't tell you that it's going to be ethane plus oxygen is going to give you a certain amount of carbon dioxide and a certain amount of water, but you just have to know that from here on out, because I tell you it's a combustion reaction. If it's a complete combustion reaction, you always end up with those products. So go ahead and write out the complete combustion reaction for ethane and then balance it. Pause the video and then we'll walk through it together. So as you can see, I'm using scrap paper, and I have that's an engine diagram on the back side of that, so just ignore the fact that you can see something there. So let's talk about the complete combustion reaction of ethane. So I'm calling this ethane. You don't have to know the name of it, but you can just know this as an organic compound because it's got carbon and hydrogen in it. It's a hydrocarbon, all right? And because I'm talking about the complete combustion reaction, you need to know that oxygen is going to be a reactant, and then you're going to always have 2 products. You're going to have carbon dioxide, and you're going to have water. So you write it out like that. So that's our first step. Now all we got to do is balance the equation, and we are done. Whoops, I missed your A2H2O over here. So let me rewrite this so I might be able to slide it so you can see that part there. And, well, you get the idea. Now I've lost my carbon over here, but you can kind of see where it is. I'm going to move it back so we can see both of them. There we go. All right, let's balance this. I'll let you do it, and then we'll do it together. All right, so let's walk through it together. So anytime you have something like oxygen all by itself here, balance that oxygen the very last. So we're going to start by balancing the things that are, together in a molecule already, the carbon and the hydrogen. So if I have 2 carbons over here, I know I have to have 2 over there. I got to do that much. We're not going to worry about the oxygens just yet, but obviously now we have 4 oxygens associated with that. But let's go back to the hydrogen. I have 6 over here, so I'm going to have 6 over there. So I'm going to make that a 3. All right, now everything is balanced except for the oxygen. So now I'm going to balance my oxygens. Let's see how many I have total. I have 3 times 2, 6 here. Whoops, excuse me. 2 times 2, that's a 2. I can't even read my own writing. 2 times 2, there is 4 oxygens there. And I have 3 oxygens over here. So I have 7 oxygens total on this side. So we're going to use our same trick that we did over here to balance it. If I say that I have 7 halves of oxygen molecules, that's the same thing as saying that I have 7 single oxygens, and that's what I've got over here. So now, once again, my equation is balanced, but it's got this ichio fraction in it that I've got to get rid of. And so I can get rid of that simply by multiplying everything in this equation by 2, and that should get rid of this fraction as well as balance everything out. So let's go through that. I'm going to say that I have 2 C2H6 plus, when I multiply 2 times 7 halves O2, I end up with 7 O2. When I multiply 2 times CO2, I get 4 carbon dioxide. And 2 times 3 H2O, I get 6 H2O. There we go. And now we're just looking to see if we're balanced. Let's see how many carbons I have on this side. Well, I have 2 over there. Excuse me, I have 4 over there, and I have 4 there. How many hydrogens? I have 12 here. Oh, I got 12 there. How many oxygens? Well, I have 14 here. Now let's see if we add up to 14 here. I have 8 on that side and 6 on that side, and sure enough, 8 plus 6 is 14, and we balanced our reaction. All right, so I'm going to let you do butane all by yourself. See if you can figure that one out. And then we're going to go on to incomplete combustion reactions. Oops, I misspoke. So I want you to also do heptane, that's C7H16, as well as butane, C4H10. Do those on your own. And the way I did it, probably similar to what you did, I wrote out my C7H16 plus O2. It's going to produce carbon dioxide and water. I balance the stuff, everything but the oxygen, so I balance my carbons. I have to put a 7 over here. I balance my hydrogens. I have to put an 8 over there because I have 16 there. And now, because I have a 7 here, and that means I have 14 oxygens there, and I have 8 oxygens there. So I have a total of 22 oxygens on this side. And the beauty is I don't have to do any fractions over here because I know 11 times 2 will give me 22. So my balanced equation is C7H16 plus 11O2. So I got 20 hydrogens. Over here, let's see how many oxygens I have. So here I have 13 times 2 is 26 on this side. Here I have 16 oxygens plus 10 oxygens. If I add those two together, I get what we want. There we go. So we've solved that one. All right, so just a quick review. Complete combustion, oxygen is always a reactant. Carbon dioxide and water are always products. You just need to know that. All right, we're going to look at incomplete combustion now. Incomplete combustion is combustion that occurs when there's not enough oxygen to completely react with carbon source so that carbon, carbon monoxide, as well as carbon dioxide and water vapor are usually produced. And that's just what I'm showing you here. I have this generic hydrocarbon. It doesn't have enough oxygen. When that happens, I produce carbon, which is black soot, carbon monoxide, as well as carbon dioxide, and then the usual water products. So you need to know from here on out that any incomplete combustion reaction, it includes a couple of other things. It's going to include carbon as well as carbon dioxide. I would always give you a reaction, and all you would have to do is balance it, so you could figure that out. But that's what an incomplete combustion reaction looks like. Okay, that does it for the first chunk of Module 5. We dealt with 3 different kinds of reactions: decomposition, formation, and combustion. And you need to be able to work those out if I give you an example. And on your quiz, I'll give you an example of each of those, and you'll have to solve for them.